Thanks for having me and the invitation. Hopefully it'll keep you engaged, interested, and have some good discussions here. So I'd like, as we talked about in that last survey, operational excellence, productivity, some of those relate to my role and function as it relates to quality, right? We need to have good quality. We can't be throwing things out, wasting and reworking, et cetera. So we're going to talk about that as it relates to the analytics and really what's been driving the market that I'm working in with Air Liquide Advanced Materials and how we're adding value. So first, I'd like to just get to an executive summary and cut to the chase. People are asking about ROI. Here it is in a nutshell. So in roughly 2 months of time, we were able to take a look at SOP, a standard operating procedure, for an instrumented but not automated process, understand our variation. We talked about implementing SPC control. We saw some modest improvement in the statistical control limits. And then we actually did it. And we said, okay, we're going to use a new tool and implement SPC control. And did we have some rule violations? Absolutely. Did our control limits tighten? Yes, absolutely. So when we look at ROI, in 2 months of time with some focused attention, we were really able to drive for a more consistent output. We're not looking to be better, we're looking to be consistent and make things the same. This improvement happened the middle of last year, but there was a lot of system infrastructure that kind of went into that to make this change happen. And so I'd like to go through that with you here for the rest of the presentation. If I lose you, I will take comfort in the fact that the electronic devices that you're using, smartphones and et cetera, essentially every single one of them has Air Liquide Advanced Materials products inside of them. So thank you very much. But I'd like to keep you interested instead and focused on this information. So we're headquartered Air Liquide Advanced Materials in New Jersey. We're a global business unit that develops precursor chemicals. These are organic, metallic, or metal organic molecules, very small molecular weight that are used to deposit successive layers on chips in fab plants of the world to make memory and logic chips as well as disk drives. Unlike the rest of Air Liquide, we do make solids, liquids, and gases. So maybe you know Air Liquide from large industry or healthcare business units. This is a small global unit that really is the world leader in supplying molecules for chemical vapor and atomic layer deposition of chemicals. And it's really a fascinating industry to work in for electronic semiconductor manufacturing, where for every node of technology, maybe 1 or 2 molecules will be adopted and brought on. But for us, we're typically developing a library of close to 100 molecules in the portfolio to make sure we have the right one ready when it's time. As a consequence, you may have something that's in a pilot plant and suddenly, before you know it, you're ready to go live and full scale. But full scale can only mean maybe 10 to 100 kilos of material, and that's the world supply for a year. So it's very high purity, small volume chemical manufacturing. So what made this journey interesting for us? It really was interesting because Air Liquide Advanced Materials is part of a merger between Air Liquide and Voltaics. But when you look at that, that's nothing special. It's also nothing special that we have procurement departments that like dual source strategies, things like that. And so when you talk about, wow, I'd really like a system that is able to pool all of the data together and bring it to one place where I can look at it on a global basis or at a very discrete basis, it becomes a little bit of a challenge. And you say, wow, how do I deal with those procurement strategies, level of control solutions? You know, am I working with a process control room, maybe a human machine interface right there on the plant floor? How do I integrate all of this and then bring it into a useful tool for process control and quality? So we have all of those kind of soft challenges. Regardless, our customers are expecting improvements, continual improvements, which means not necessarily better, just make it more the same. So how small is small? So when we talk about the joys of our cell phones and Siri and Alexa and autonomous vehicles and all of that, you know, we're getting down to nodes that are 10 nanometers in spacing. Technology, Moore's law is driving us down to 3 and 5 nanometer spacing. And so just capturing an image off of an article from Intel's 10 nanometer spacing that they have here, you know, we're talking about 40 atoms of iron stacked next to each other, right? So that can create voltage leaks, that can create defects on a chip, which can take upwards of 6 months to manufacture. So, you know, when you start off at that human hair and really drill down, we're talking about some really interesting chemicals now that are used to make up these structures, fascinating manufacturing processes as well. So the industry standards, you know, they've changed kind of as part of Moore's law. So when you take a look at in other industries, they ship to spec. You make a material, you say, here it is, here's the analytics to it. Are you okay to buy it? And they'll say, yeah, sure. But as we got down to smaller nodes, suddenly, you know, people would do cherry picking for certain customers who like it a certain way. Then you're on to fitness of use. Okay, we'll send you a pre-ship sample and see if you like it. If it works, great. If it doesn't, we'll send you another one, right? We're now moving into a different regime. Currently, we're in this ship-to-control regime where we need to prove that when we made the product, we made it in control. Not only the manufacturing parameters, but as well as the analytical values that are used to assess the product itself. So part of that is inclusion of manufacturing parameters on a certificate of analysis. That could be temperatures, pressures, flow rates. How do we prove that when this was made, it was made in control? This is where I feel the electronic industry deviates from the pharmaceutical industry, where pharmaceutical, you have a pharmacopoeia standard, it's very structured, and there's the recipe, and you do it, and it's kind of like meeting to spec. This is amping that up on steroids and saying, hey, you need to prove that you're in control. Where it's headed for the 3 to 7 nanometers is real-time lot trace regression analysis. And so that's where our customers would like to have and for us to share real-time process data with them so that they understand any variation that might cause a problem when they ultimately use the chemical on their tool to make a wafer. So when we talk about digitization, industrialization, and Industry 4.0 and things like that, not only do we want to do it for ourselves, our customers are also expecting it as well, and we need to deliver. So ship to control is kind of that new thing, I guess, that we're moving into. They're not fixed. They're like taxes. Once you add one, they never go away. They're like taxes also, where they never get better for you. They typically shrink, and that's because of things that we do to ourselves called continuous improvement, right? So we always get better. Those control limits shrink, and we continue along that journey. So we are an expanding business. We needed an automated solution and really to help us with the amount of data that we were starting to get ourselves into as we commissioned more plants, more products became commercialized. And just a note on this graph, the reason why I wanted to show this is, we have these leading indicators and lagging indicators, very similar to a safety pyramid type concept, right? The lagging indicator is we scrapped material, or worst case, we had a customer complaint, right? In-process SPC rule violations is somewhere in the middle, but there are some other items up here that are more on the preventative side that we can capture and take advantage of overall from a process improvement standpoint. So with this mindset, we ended up looking for a shop floor system. We wanted something for our operators to use. We ended up selecting the Northwest Analytics EMI Focus software as the solution to implement. And why did we do that? It was a good fit for all the boxes that we wanted to check off. It also provided us a platform to gather all of the process data from these various systems. Other solutions that we looked at the time, which was approximately 3 years ago, didn't give us exactly what we were looking for. And so from an architecture standpoint, as I mentioned before, we do have a pretty diverse manufacturing process. These are all typically batch processes, semi-continuous. Again, it's HMI screens from various vendors, control rooms. So we were taking all of that. From an architecture standpoint, we passed it into a Kepware server, into a SQL database, and then using the Northwest Analytics, we had an output that was functional for end users to take a look at the visual representation of our data. For the part of the pie chart of folks that were thinking about implementing things on the survey, a design consideration is to know that customer. So we started out with the idea of being scalable to multiple plants. And as we had that as a design requirement and began our rollout, we also realized it needed to be scalable to the end user as well. We just had some different end user expectations, number of tags, for example, that were in the system. Some people wanted everything. I want everything, give me everything. From a quality standpoint and from an operator standpoint, no, we needed to separate those vital few from the critical many. Right, so what is that critical quality control element out there that we need an operator to absolutely pay focused attention to and have an appropriate response flow checklist? Of course, there's safety alarms and things like that, but we're focused on quality here in the discussion. Recording frequency is another one, right? So how often do we need to have this refreshed? There are statistical ways that you could look at and say, well, let's look at the response time of my process, and maybe I use that to do my recording frequency. Another way to look at it on the other extreme is, well, how often does an operator look at the HMI screen to begin with today? Somewhere between those is a happy medium, probably where you would land as far as how often you're refreshing your data. And then time span. Right? When we talk about statistical process control, this is supposed to be real time. Do we need 5 minutes of data? Do we need 15, 1 week? What makes sense for a person to take a look at the data and really understand, okay, I can apply an SPC rule, but I also want to put this data in context to everything else that's going on and what a long-term trend may look like. And it depends on whether or not it's an operator or a supervisor or maybe someone from maintenance and quality, right? Finally, on this side, from a design consideration, don't overlook the what's in it for me. We kind of talked about that. In this case, it was the operator that we were looking for. Traditionally, it's not that we weren't looking at the data, it was that it was being recorded by hand on sheets of paper for routes and rounds. okay, we're introducing a new tool onto the shop floor. What makes it exciting for them? They have another computer now that they have to look at, another software program to look at. Okay, well, what's in it for me? For that operator, we can say, hey, no longer are you going to have to spend time writing things down. We're going to have less transcription errors. It's going to be automated. We want you to control the process rather than doing administrative type tasks. So it really improves their efficiency. Also on the survey, someone mentioned, a couple people mentioned and noted about training and support. So as part of implementation, we developed a core set of slides and information talking about statistical background, what rules we're going to apply. We selected a demonstration tag, and we expected it to be relatively simple, but that was the string, and once we pulled on that string, the whole ball of yarn just exploded. And we found out some really wonderful items that, you know, there were gaps that we had in our own process where we would have instructions that would have a range with no target. And because of that, operators had preferences that they would use. So we would have shift-to-shift differences, person-to-person differences. Once we did that, we aligned on a value, and we asked the operators, hey, write down what you do for 2 weeks. When you make an adjustment, what is that adjustment? What are the steps that you took? And if you can, what caused you to feel the need to make an adjustment? And so that helped us develop the response flow checklist. And as we did that, this is the example that I had showed in the beginning, and the results were dramatic. At the same time that this was going on, we were rolling this out to the rest of our facilities. Within Air Liquide Advanced Materials, we had another business unit over in Singapore who was looking to do a similar project but with analytical values. They were able to apply our architecture and roadmap and really was able to accelerate the implementation of their program. We had some additional benefits. Now that we had all this data, we found some other interesting things we could do. We could take a look at our data and say, well, you know, we have these process steps, and one of the steps can be equipment downtime when the item isn't running, right? So, hey, why don't we use this to track now our operational excellence efficiency, right? Now we don't have, again, this was a case where it was being recorded by the operator. What step were they on? How much downtime did they have? Things like that. We removed any subjectivity now because we were just using pure data to say, okay, here's where we were for our different steps, and here's the equipment downtime that we had. And there were other interesting things that we saw with this data access. Okay, what else can we do beyond SPC control? So we looked at long-term monitoring of analytics to assist in planning routine maintenance. We knew for certain filters we would see trends in our data that would signal to us, hey, we need to go and perform a maintenance. And it became a scheduled maintenance now rather than a break fix. The other thing that it allows us to do, because we're operating on a global platform across multiple plants, is we're able to do tool matching. And so this is making sure that when we're making the same product at multiple factories, that the mean and sigma values of all the different attributes are within statistical norms of each other. So we're able to do that now much more efficiently using this software and the ability to the data access. And finally, it allows for global troubleshooting and global visibility of process data. So we've incorporated this into our design standard for new capital projects so that it gets implemented and grows with the company. We just commissioned a new facility over in Korea. It was part of the design process. We're able to have our engineers in the US look at the data virtually real time. There's about a 10-minute delay the way we've structured our data transfer, but 10 minutes isn't so bad when you think about it. And they're able to do troubleshooting. So it works out very efficiently, and it's a 10-minute delay is a lot faster than 14 hours on a plane. So what's next? Where do we go from here? Internally within our company, we're in the business unit, we're, as I said, using this as a minimum design standard. Right? We're going to continue to expand it within our current operations. And we're really taking a purposeful, stepwise approach to implementing it. So we want to make sure that we have all of the buy-in necessary from the operator, the process engineer, the supervisor, the site leader, to make sure that they understand and can realize the value. Long term, for me, it's really interesting to see where process control is going to go next, as far as where does artificial intelligence affect how we do things for process control. An example would be tuning parameters for valves, when you look at the traditional PID tuning parameters. So hopefully this gives you a feel for the electronics industry, what the expectations are for chemicals that go into manufacturing the memory and logic chips that go into a lot of the things that we use today, many of the things that we use tomorrow. And I'd like to thank you very much for your time.